Right, so we're already recording on cloud and live on Facebook. So I'll pass the session to Gauri. So you may start whenever you are ready. Thank you.
Okay. Is Madam Norhana ready?
Yep, I'm ready.
Okay, then I'll start. A very good evening to everyone who has joined us tonight through Zoom and Facebook Live for the 7th installment of our ANSARA Muda Career Talk Master Series. A very special thanks to our strategic partners, Unit Perkhidmatan Bimbingan dan Counseling MRSM Taiping, Center of Foundation Studies University Technology Petronas, TNF Energy Sendirian Berhad, Amans Media, and Outputs Taiping, for providing us with this wonderful platform to share knowledge. Before we move further, I would like to invite our Muslim friends in the audience to recite Kitab al-Fatiha. So before we proceed, I have a small reminder for our UTP students. Please scan the QR code given on the screen that's being shared now so that you can take part in the survey. Today we have with us an industrial expert with 18 years experience in a field of expertise. Now the career talk for today is on petroleum engineering from our special guest, Madam Norhana binti Harun, ANSARA Taiping batch 94. Currently, she is the General Manager of Value Assurance PETRONAS Upstream, which is a component of risk management. We'd love your participation in this talk. So for any questions, you can use the chat box in Zoom or the comment section in Facebook. Without further ado, I invite Madam Norhana to the screen.
Thank you, Gary. Right, I'll be sharing my screen now.
Okay, I can see.
All right, just give me a second. Right, Assalamualaikum, a very good evening or good morning or afternoon, wherever you are in the world. It's excellent that we get to see you virtually. And I would like to share with you my career talk with the title Career in Petroleum Engineering. My name is Norhana binti Harun, as introduced by Gauri, and I'm gonna show you what petroleum engineering is all about. Right, may I just check, do you see my header at the top? Does it disturb the screen?
No, I can see about me.
Okay, excellent. Right, so let me introduce myself first. I'm currently a General Manager in Value Assurance of Upstream Risk and Assurance, and Gauri has rightfully mentioned. It is a part of risk management under Finance and Risk Division of PETRONAS Upstream. I was previously a PETRONAS scholar, and I'm proud to be an employee of PETRONAS for 21 years now. I was born on 26 October 1977 in Batu Gajah, Perak, which is very close to where UTP is. But I was brought up in multiple states within Malaysia, namely Perak, Perlis, Penang, and of course, Federal Territory of Kuala Lumpur. So a brief history of my education. I started schooling in 1984 in Bukit Bintang Girls' School, Kuala Lumpur, primary and secondary school. And I entered MRSM Taiping when I was in Form 4, and I stayed there until Form 5, and I was a pure science stream student of MRSM Taiping back then in 1993. And in 1995, I was offered a position to pursue my education in what was called Institute Technology Petronas, and now it has been called UTP. So it was an associate degree in gas technology. So UTP used to have a Petronas logo with the word Institute Technology Petronas on it. And later down the road, after 3 years at Institute Technology Petronas, we took over the campus, the University Science Malaysia campus in Toronto, Perak. And at that time, the university wasn't ready to prepare us for 4th year and 5th year of the course. So we were distributed to multiple universities across the globe. So some of the people in our batches were sent to Harriet Ward University, some to University of Calgary in UK, some to University of Surrey, and myself, I was assigned to University of Strathclyde in Glasgow, Scotland in the UK. And you can see there is a shift from associate degree in gas technology to a degree in chemical engineering. It was a credit transfer into this degree. I graduated in the year 2000 with a Bachelor of Engineering honors in chemical engineering. And I started work with PETRONAS in the same year. And I was employed in PETRONAS as a petroleum engineer, although my degree was chemical engineering. So after a few years in service with PETRONAS, PETRONAS offered a conversion program scheme for its staff, and I was selected to be part of the scheme. So I rejoined now University Technology PETRONAS, and because it was a pioneer program, so UTP had a collaboration with Harriet Ward University in the UK. So we've got lecturers from UK coming over to UTP to teach us petroleum engineering subject. And we stayed there on a part-time course. So we would spend a few weeks within a month for a year. And then half a year later, it was full-time at the campus itself. So I graduated with a master's in petroleum engineering from UTP. And since then, the only lesson that I'm taking right now is piano class. And just to let you know, I started in 2012 and I'm now in grade 3 or 4 stage. Right, I would like to share with you about UTP, since this program that you are experiencing tonight is partially sponsored by UTP. So UTP, or University Technology PETRONAS, is one of Malaysia's top university for petroleum engineering degree. And if you have the time, I would like to invite you to visit some of these hyperlinks that I've put up on screen to learn more about the foundation program. And there are really good videos on testimonials of UTP foundation program by the students. If you like to see more about UTP facilities, you can see them online as well. And UTP has now introduced a new feature which has just gone live on UTP live chat, where you will be able to learn more about the university programs and offerings. Like I mentioned, I'm a graduate of UTP, and I'm proud to say that I'm an alumni of UTP. So this used to be my matrix card. Like I mentioned, we have lecturers from Harriet Ward universities. So there are times that our lecturers could not come over to Malaysia. So we had to do a video conference call to learn the subject. So we did video conferencing in PETRONAS Twin Towers facilities. And of course, the great library UTP has is, I think it's one of the most beautiful libraries I've seen in my life. And of course, sweet memories with my colleagues. These are all PETRONAS staff that was enrolled under this program to be a convert to a petroleum engineer. These are all non-petroleum engineering people who are converted to become a PE. And glad to see we graduated, all of us passed the course with flying colors. So what I'm going to do now is to share some pictures about life as petroleum engineer. So of course, petroleum engineering requires us to work with oil and gas, and most of the oil and gas accumulations in Malaysia are mainly offshore. So here are some of pictures of me and some of the facilities that we have in offshore locations, Malaysia, on some of the oil and gas facilities. So you can see they have a lot of shapes and structures. So these are some of few examples of the platforms that I visited. Okay, so this one is such a large complex. We also have a very simple platform structures, and we also have integrated platform structures like what you see in this picture. And this is me during my younger days. I think this is in the year 2001 or 2002. I was on my trip to one of the satellite platforms to learn about petroleum engineering. And the reason being, is that, I was a chemical engineer. So in order to know more about petroleum engineering, I've got to get my hands dirty. So I had to do some platform visits to be friends with the technicians offshore, to learn about the fundamentals of petroleum engineering, production facilities, how to do the testing. So this is me with some of the measuring cylinder units just to check the water content in the oil. And this is a picture of me on a fast crew boat on my way back home after 1 week trip offshore. As you can see, I was smiling very proudly that I've learned so much during my trip. So more to come are more pictures just to excite you on what life as a petroleum engineers look like. So these are some of the later years of my career in PETRONAS. So of course, I visited some of the platforms again. So we sometimes travel by boat, sometimes we travel by the helicopter, or we say chopper. So if we get to ride by chopper, it's usually a really nice ride because it's probably just 20 to 30 minutes. But if we take boat, it could take 2 to 3 hours ride on the boat. So sometimes we get seasick. And this is the picture of us inside one of the nicest boats that we have. And sometimes as petroleum engineers, we've got to learn about the geology. So we do geological field trips. Like this example, I was at Pantai Kemasit in Kerteh. So we brought in a few people to learn about rocks. So we learn about what faults and fractures look like so that we can imagine, what we see in the outcrop is what it is a few hundred meters down below where the oil and gas accumulations are. So I've also been involved in unconventional drilling. This is a shale gas field in Canada. So back in the year 2013 or so, I was in Canada to learn about shale gas. So what you see here is a thick block of ice in Canada. And this is where we store the water that we use for hydraulic fracturing in the wells. More pictures. So in Canada, for example, this is drilling on land as opposed to Malaysia, where we mainly do drilling offshore by a few kilometers away from our beach front. This is actually on land. And we can only drill during winter time when there is snow. During summer, this place is going to be like a marshland. The water will be seeped into the ground and it's like a muddy area for us to work on. So we can't carry our heavy equipment. The truck cannot be driven on the surface of the ground. So you can see the challenge is to really drill the oil and gas, and in this case, shale gas during winter time. So these are some of the pictures of my team when we were there, and we had to take a private jet to the nearest airport facilities and another 2 hours drive by 4x4 vehicle in order to drive to this particular location. Right, so we do also have onshore location elsewhere. So these are some of my borrowed pictures from my colleagues who've been working in the Saharan areas, in the African regions. So it's quite a challenging place to work. Okay, and this is me in one of the drilling rigs. This is the drilling rig I was talking about. This is one of a semi-submersible. And at this drilling rig, at the drill floor, this is what we call a driller. So they will actually do the drilling. And this is the opening of the well, or we call it well bore, for us to start drilling underground, for us to go to the target for the oil and gas reservoirs. And of course, before we are able to travel to offshore, we need to be trained in basic offshore safety induction and evacuation training. So we are being trained, what if when we travel by helicopter, the helicopter crashes? So we've got to learn how to evacuate if the helicopter is at the surface and they will submerge this helicopter underwater. We've got to learn how to open the window of the helicopter underwater while holding our breath. And of course, they also will do it and they will turn the helicopter upside down and purposely do so to disorientate you and for you to learn also how to evacuate in the event that the helicopter ditching is on water, submerged, and overturned. So these are some of the emergency trainings any petroleum engineer has to go through, or anybody who works offshore must go through. And we also learn how to do this group ring, they call it human ring, for us to evacuate. And this is one example of the life raft that we use. And these are part of the safety equipments that we have on board when we work offshore. So I must say that working offshore is actually quite a safe experience. We have very good safety measures. So of course, incidents may happen on uncontrolled situations, but it's very rare because we do have very good safety and strict control measures when we work with live hydrocarbons on screen. Right, so there are some pictures just to get you excited and have a flavor of what petroleum engineering is all about. I think it's only fair that I make things as simple as possible for all of you to digest. I know some of you are still in school, some of you are at universities, but let's bring things more simpler enough for all of us to digest together, yeah? So let's learn about some oil and gas terminology so that you have a feel of dimension. Okay, when we talk about oil volume is measured in barrels. So in oil and gas industry, we use the acronym BBL. B for blue, the color blue, and BL is for barrels. So because usually in the olden days, oil are being stored in blue barrels. So that's why you see BBL as an acronym. So how much really is 1 barrel of oil? So 1 barrel of oil is about 158.9 liters. So if you're familiar with the car Perodua Myvi, typically it has a fuel tank volume of about 40 liters. So with 1 barrel of oil, you can actually fill up 4 Perodua Myvis. Yeah. So what about gas? Okay, gas is a volume that is measured in standard cubic feet. Okay, and 1 standard cubic feet is about 28.3 liters. So if you know of this in Kuala Lumpur, we typically have a 60-liter natural gas vehicle tank or NGV tank. So with 1 standard cubic feet of gas, you can fill up 2. You can fill up 1 taxi with 2 standard cubic feet of gas. So that's what it feels like to have 1 barrel of oil and 1 standard cubic feet of gas, right? So now that you know what barrels and standard cubic feet are in oil and gas world, I'm gonna now move into the topic of introduction to petroleum engineering and its sub-disciplines. I have shared with you life as petroleum engineers, and I would like to share with you some challenges in oil and gas industry. So bear with me over the next 20 minutes or so. So I'll walk you through all the slides. To make things more interesting, I've prepared or sourced a video that speaks about the oil and gas industry. So I'm gonna play this video now. Let's see if it works.
Oil and gas are generated from a source rock, organic matter buried in the depths of the earth. Once formed, they climb back towards the surface. On their way, cap rocks can impede their progress, and they accumulate in reservoir rocks. Here, they constitute hydrocarbon fields, which can be identified by interpreting seismic data. a sort of echography. The data is obtained with the help of a seismic ship. To confirm the interpretations of seismic data, two types of drilling gear exist. Each is adapted to a range of depth of water down to more than 2,500 meters. The platform seen here is a semi-submersible which floats and retains its stabilized position by means of anchors fixed on the seabed. Platforms at sea are used not only for drilling, but also for the production of hydrocarbons. This production consists of the separation of oil, gas, and water before the oil and gas is taken by pipeline towards a mainland terminal. Where it's impossible or too expensive to link the field to the coast by a pipeline, an FPSO ship is used, floating production storage and offloading barge. On board, the hydrocarbons and the water are separated. The oil is stored prior to being loaded on tankers, and the gas is re-injected into the reservoir rocks. Gas from a field is taken to land through an underground gasoduct to a processing plant. There, if the gas is to be transported by sea, it's converted into liquid, obtained by cooling it down to minus 163 degrees Celsius. When it arrives at the plant terminal, the liquid natural gas, LNG, is returned to its gaseous state in a regasification plant before being introduced into the local gasoduct network. The LNG is stored in tanks before regasification. The crude oil is transported in a petroleum tanker, the capacity of which can attain 200,000 tons. It's commonly called a supertanker. The terminals capable of receiving such giants are few and far between. The ships used to transport the crude oil produced on an FPSO ship are of a much smaller capacity. The crude oil, before being refined, is stored in the port in large capacity tanks. The natural gas is preserved in reservoirs, artificial or natural. It's ready to be injected by pumping into the gasoduct network for industrial and domestic use, or as fuel in power generating stations. As far as the crude oil goes, it's transported by oleoduct to the refinery. There it undergoes a number of transformations and blending. A variety of finished products are obtained: LPG, petrol, kerosene, diesel, or naphtha, which will be used as the basis for the composition of plastic product. Two types of drilling gear exist.
Right, so that's a short 2 or 3 minutes video about oil and gas. So now I'm gonna walk you through about career in petroleum engineering and the sort of hydrocarbons that we work with. I like this picture particularly because it describes the whole petroleum system. So you can see for us to have a petroleum system, we need to have source rock. So typically source rock can be shale. And we need to have a reservoir. So a reservoir can be in many types. We need to have migration of these hydrocarbon sources into a trap or seal. So sometimes what we get is just gas, and sometimes what we get is a combination of gas and oil presence. Sometimes gas are captured in tight gas sand. And in the shallower surface in some parts of the world, we have gas in what we call coal, and they cover an extensive area, and we call them coal bed methane, particularly because they have high concentration of methane gas. Right. So typically, as petroleum engineers, we are involved in what we call a life or field of a petroleum engineering world. So we can start the activity with acquisition, with exploration, development, production, as well as abandonment. So we can be onshore and we can also be offshore. And offshore, we can work at shallow water conditions. We can work in deep water conditions. And we also can work in ultra deep water conditions. Right. Of course, with increasing levels of water depth, the degree of technical complexity also increases. More and more advanced technologies are being used for us to explore and exploit the oil and gas offshore. So typically in shallow waters, we use a fixed platform or a compliant tower. So in Malaysia environment, in our shallow waters, we typically have fixed platform. And in slightly deeper water, as we move out of the continental shelf towards the deepest part of the continent, we get varying types of rigs that we use. We have sea star, we have floating production systems. There are tension leg platform. There are also subsea wellheads that we can connect to either one of these facilities. And we also have what we call a spa platform. Right, so these are some of a good picture of how a subsea wellhead look like in very, very deep waters. So we typically have, a large number of subsea wellheads, and we call these wet tree units, and they are connected to a production manifold that is also in the subsea condition, and they may be connected via an umbilical to any of these facilities. They may be here, in this case, a floating ship, drill ship, or in this case could be a tension leg platform, a spa, or this one is of course a semi-submersible for us to do the drilling. So it's really interesting how wide a spectrum of where petroleum engineers can work. And of course, with higher degree of complexity, the work gets tougher and more interesting for some. Right, so for your information, there are many branches of petroleum engineering. So if you graduate with a petroleum engineering degree, you can be employed as a reservoir engineer, and you can be somebody who explores more about reservoir engineering, which I will talk about later. If you graduate with a PE degree, you can also be a production technologist. We also have petrophysics, and we also have drilling engineering, as well as petroleum economics. So these are just some of the many more disciplines that we have offerings or being offered by the industry. These are the typical ones that PETRONAS offer. But if you do not work with PETRONAS or you work with the service industries, the type of petroleum engineering subdisciplines are much, much more specialized. You probably have very specific skills, very, very deep technology knowledge that you offer for PETRONAS, but for any oil and gas industry, for the sake of discussion. But for today, I will just be focusing on this 5. And let's start with reservoir engineering. Okay, so if you are a reservoir engineer, what you do is that you study the reservoir fluid and the fluid rock properties. You will monitor reservoir performance. For example, in this diagram, you need to see how much oil and gas are you producing over time. And you also need to monitor how much water you produce as a byproduct of this production of oil and gas. And you need to devise methods to improve reservoir performance and devise an optimum field development plan. So if you like computer modeling, 3D modeling, I think this would be a good career option for you, because we do a lot of 3D dynamic modeling. So you can see these are pictures of grid cells where we simulate how the reservoir looks like underground. And from this 3D model, we can decide, where we want to drill our oil and gas wells, depending on where the oil and gas are located. Okay, and we do rely a lot on unseen things, but physical hard data like pressures. So pressures are actually very important. So there is a lot of pressure when you work in reservoir engineering. Right, I'm going to talk now about production technology. Right, as a production technology, you mainly would work on hardwares. So you would select the appropriate tools to monitor the well performance. You would analyze well performance by using nodal analysis. So this is one example of what a nodal analysis look like. And also you formulate well completion strategy and design. So here is a picture of what an oil and gas wellhead look like. So as a production technologist, you may advise what type of material that is suited for this kind of fluid environment. So if the reservoir pressure is very high, we probably need to use a different type of well design. And this is what we call a Christmas tree. Yep, a Christmas tree. So this is what we call a Christmas tree, or another word for this will be a dry tree unit, because it's dry comparatively to the wet tree unit, which is submerged at the subsea area. Right, underneath, you would also decide what kind of completion dimensions that you're going to use. Sometimes we use a lot of what we call jewelries. These are all very expensive equipment that we put in the well. And, you know, if we were to draw it on a piece of paper, typically, you know, under this Christmas tree, these are all the equipments that we have within the well bore. So a production technology will decide what type of equipment, what kind of perforations we're going to use, what kind of liquid that we are going to produce, and how do we manage them over time. So sometimes we are required to work integratedly. So we do have integrated operations where we rely on, you know, satellites to transmit data from the drilling rig to our remote shore-based facilities. So it may be in PETRONAS Twin Towers, or it may be anywhere we are operating in the world. Okay, and you know, some of these data will need to be transmitted via private networks. We use a lot of telecommunications provided by Telecom Malaysia to underground cables as well. So these are all key success factors in running any integrated operations very well. We do need this to transmit data. We do need to have a well status monitoring. So if we can map all of our oil and gas wells, we are able to tell, you know, how much oil each well is producing, how much water, how much gas are we having, and you know, a typical reservoir engineer and production technologies combined will need to do a day-to-day well production monitoring, and we do need to analyze how our wells are performing. Right, now I'm going to move to the next subdiscipline, which is petrophysics. Right, if we are employed as petrophysicists, what we do is actually we acquire data from the wells in order to study the reservoirs. So we also need to choose the appropriate tool and method of data acquisition. We identify the presence of oil and gas, and also we evaluate the properties of the reservoir. So this really is a combination of good physics and sciences. So we also need to do some mathematical correlations if we are petrophysics. So we look at the data about porosity. Porosity is, you know, the holes that we have inside a piece of rock, and also permeability. So permeability is the ease of fluid to flow inside a porous media. Okay, and this is a typical electric signal response from a drill stem test. So it looks like, you know, if you are a cardiologist, you read ECG diagram. I think this is something similar. You look at the diagram and you interpret, what is this? what does this line means? Are you okay? Or do we have hydrocarbon presence, or do we have water, or do we have gas? What is the fluid will be characterized by the pattern of this electrical response. Right, we also have drilling engineering. So if you like action, if you like the hard, physical, rough environment, I think drilling engineering would suit you. And what do drilling engineers do? They actually conduct efficient drilling. So all the pictures that you've seen before, the drilling rigs, that's where your work location would mainly be. So you would be planning a well design. For example, in this picture, you know, our semi-submersible drilling rig would probably be a few kilometers away, and your target could be 2 or 3 kilometers away from your drill center. And so you need to devise a drilling program, plan for it, and make sure you reach the target. And you use a lot of drilling equipment. So these are some of pictures of our drilling tool. Okay, some are made of diamonds, some are made of carbon tungsten carbide, you know, so these are all the drilling bits, we call it. Okay, and we also need to plan and select what would be the most suitable rig. So depending on where we locate the water depth and also the power that we need in order to drill all the way to a very, very far location, you probably want to decide all of these before you do the drilling program and to choose the appropriate tool for the job. So this is what I mentioned earlier, a typical picture of the drill floor. So these are what we call drillers. They're busy working. It's a hard labor, but this is not petroleum engineering. These are drillers. So drilling engineering would actually advise the contractor to do the job. So typically a drilling rig is actually quite huge. So if this is a production platform, this gray thing is the drilling rig. It's huge. So they have a cantilever that will push this drilling rig to be on top of this production platform, and they will drill a well through this platform pillar. So in other environments, the rig could be this kind of rig. And in land conditions, it's very simple. It's relatively cheaper compared to offshore drilling. And this is how it looks like. Right. There's another branch of petroleum engineering, which is petroleum economics. So if we are a petroleum economist, we normally would conduct economic feasibility studies. We interpret contracts to develop cash models, and we also analyze project value. So this would interest you if you are strong in mathematics, if you like commercial subjects. This, I think, would be a good subdiscipline for you. So we will typically learn or analyze what will be the net present value for a given project, given the sensitivity in the oil production, oil price, the capital expenditure or CAPEX, or operating expenditure or OPEX. Okay. And petroleum economics role is actually very important in advising the decision makers whether we will make money or not by the end of the project life. So typically we will spend a lot of money. There is a big cash sink during the development phase. And as you start production, you will get more revenue, and you will see that at the end of the day, you probably also need to spend some money to abandon those wells that you have drilled. Okay, right. So I've shown you pictures of life as petroleum engineers. Like I mentioned, it's quite interesting. It's not just about working offshore. Most petroleum engineers would work in office environment, or they may work in the yards if you are in the contractor service. Sometimes you are also working in the production lab, like a research lab as well. So that is how diverse petroleum engineering career may be. Now let's talk about challenges in oil and gas industry. So I'm mindful of the time now, it's 21:38. Okay, so oil and gas is actually not always a glamorous business. It also comes with it a lot of challenges. So as a petroleum engineer, we typically struggle to make sure the organization that we work with can maintain a good tolerable cost profile. So the lower you can, the better. But normally it does not mean that the lowest option is the better. So there is really a trade-off between the cost that you're willing to spend and the reward that you will get out of spending the high cost. Schedule is another given challenge. So if you discover an oil and gas field, it typically would take 3 to 5 years for you to develop the field into a production platform or production environment. So the faster you bring it on stream, the better, the earlier the money you will get. Okay. And also there are a lot of technical challenges. Why? Okay. Oil and gas reservoirs behave very differently with each geographical location, wherever they may be. Sometimes we work with very high pressure and very high temperature. And that means we need to put in place a lot more safety measures. We need to decide more premium metals to use as part of our well designs. The jewelries that we use, we cannot use, just plain carbon steel. We probably need to use more premium metals in our well design. And sometimes we also have more difficult reservoir fluids. Some oils are very high in contaminants. So they probably have mercury presence in them, or high H2S, hydrogen sulfide. We also have nitrogen, and we have a lot of combination of waxy crude. Sometimes we have asphaltene present. So all of these are what we call contaminants, and the more contaminants we have, the more difficult for us to operate a field. And in some cases, we have to work in remote areas with very limited or no infrastructure. I've known of my colleagues who work in the African countries where they have to drill on land. And the first thing that they do is to build a toilet because there's no toilet. And that is basic human needs. So, it's funny how they shared their experiences. I'm also a toilet engineer when I work onshore in the African regions. It's a very, very remote area. Right. So the industry now has more deep water projects underway than ever before, largely because, the easy oil has now been exploited. So what's left is more towards the deeper part of the water. And they are more complicated, very sparse, very difficult geology conditions to work with. Okay, and sometimes certain suppliers of drilling rigs are fully booked. So we are all competing for a very limited and finite pool of resources. So during a peak oil price season, we have an extreme competition for manpower and also supplier resources. But in low oil price environment, most companies would slow down the drilling campaign because of its economic situation. They are going to be very conservative to reserve the cash. So then there will be an oversupply of resources. Right, so I've come to my 43 minutes of talking about oil and gas. I think now, Gauri, I'm gonna pass my session over to you, Gauri.
Yes, thank you, Madam Norhana, for that very informative talk. We are still waiting for questions from our students, our audience. So before I get questions from them, I would like to start with my own question for you.
Sure.
So, working upstream, working offshore, it is a field that is usually you see a lot of men in. So, how is it for you as a woman? How many colleagues, female colleagues, did you have? So, how is it different for you personally? How is it the experience?
Yes, you are right, Gauri, about the number of male and female in the petroleum engineering world. Just to give you a perspective, when I started working in PETRONAS in the year 2000, in Kota Kinabalu, Sabah, I was the only female petroleum engineer in the department, and my colleagues are all male engineers. But over time, the number of female petroleum engineers have grown, and today I'm proud to see that there is a good balance between female and male petroleum engineers. So if you ask me how I cope as a female engineer at that time, is that for me personally, I am gender neutral when it comes to work. I recognize that I am a female and I do have limitations in terms of my physical strength and the limits that I can do as a human. And so there will be times that I have to test my own limitations and to see how far I can go. But because I work most of the time in the office environment, I think it's not really a big pressure. But the situation would be different if I go and make my trips offshore. So I'm just going to like go switch back to my previous slides. Okay. Right, let me do this for a while. I'm going to go back to some pictures to show you how it's going to be difficult as a female to work in this line. Okay, let's just test life as a PE. Okay, in this picture, if you are a female and you have to do a trip to offshore rig, okay, during my younger days as a petroleum engineer, I had difficulties to secure a living quarter bed for myself because I am the only female doing the trip offshore. And you know, typically a living quarter cabin, they have 2 beds in one room. So if I that means one of the beds in the room cannot be utilized and it needs to be emptied. But at the same time, we have a lot of personnel who are male that needs to work. So beds are actually precious commodity. To have a bed offshore is actually a luxury. So because we cannot sacrifice one empty bed just to make way for one female engineer, so the trade-off that I did was I spoke to the offshore installation manager, the #1 person who has one bed in his room, and politely asked, may I use your room so that we can make way for 2 people to use the normal living quarters cabin. So really it took a lot of negotiation. They sometimes felt uncomfortable because I have to do this kind of negotiations. But in peak drilling conditions, you know, where a lot of people are required to be offshore, we need to have 100% bed available. So those kind of challenges happen. And I do remember during my younger days, we do have hot bedding where I need to share a room with a night crew. So during the daytime, that night crew will use that bed to sleep. And at night when he works, I will have to use that bed to sleep. So that was one of the extremes that I went through. But after I shared that with my boss, I had to go through that. He was quite surprised. And that condition is no longer allowed. We have to respect male and female environment. And, I also learned that, some offshore cabins were not female friendly. So, over time, the industry has started to respond with increasing number of females, and they are very cautious about, gender diversity, and they put up good infrastructures for female engineers and female non-engineers as well to come and visit offshore platforms. And I think today it's a much pleasant environment compared to how it was in my early days.
I'm glad to hear there's more gender equality now. So I have for you questions from our audience now. So the first question is from Muhammad. He's asking, can mechanical engineer work offshore?
Yes, definitely. Honestly, I felt that mechanical engineer is one of the most flexible engineering degree because for Petronas per se, we do employ a lot of mechanical engineers to become petroleum engineer, because the basics that we learn in petroleum engineering in mechanical engineer are similar. So the foundational subjects that you learn in mechanical engineering and petroleum engineering are very, very similar, but we do have extras. So it's a natural transition. It is a skill that can be learned on the job. And yes, certainly can work offshore. We have a lot of mechanical engineers who work as mechanical engineers who work offshore.
So the next question is from Hayati. She is asking about the job demand. So the current situation about job demands for petroleum engineers.
Okay. I've mentioned that the job demand is a direct relationship with the oil price. So in good oil price, typically above US dollars, $45, $50 per barrels, I think that will be a mid-range oil price where companies would decide, okay, this is a good oil price for us to make the project economic, and they will do the drilling campaign. They will do a very aggressive development plan. But anything below $45 per barrels are actually putting oil and gas companies at risk, and especially if the companies are small players, they tend to suffer a lot because they need to scale down. So it's highly seasonal, if you ask me. In current world economic condition, I think it's very volatile. There will be times where companies, they are going to bite the bullet. We're going to take risks. We're just going to continue. I know that now most oil and gas companies, they are slowing down in terms of active hiring of petroleum engineering graduates, not because they don't want to, but because they also work based on demand. So these demands, we really pray for a sustainable oil price environment. So if there is a war anywhere in the world, then the oil price may be spiked up, and that's a good environment for oil and gas company to work. Yep.
So the next question we have is from Wise. Wise wants to know, does PFLNG, also working experience in PFLNG, is it same as a typical offshore?
Okay, PFLNG, for those who don't know, if I may grab a picture. Hang on, yeah. Oh, it's at the back. Sorry. Something similar to this, but not quite. Okay. PFLNG is actually a company name for Petronas Floating Liquefied Natural Gas, PFLNG. other parts of the world, they just call it floating LNG. So floating LNG are actually big ships, but instead of having this kind of equipments, you will see, circular gas spherical tanks, and it's liquefied gas that are being processed. It's usually located very close to where an oil and gas fields are. So if, let's say, this is a production platform, there's a gas production, and they choose to evacuate the gas through the floating liquefied natural gas tankers. So the processing of the gas will happen on the ship itself. And after which, the ship will go away and pass, or sell this liquefied LNG to their target customers. So the highest consumers of LNG are mainly in Japan, Taiwan, Korea. So these are countries which have high requirements for LNG being exported. So the question is, is it the same?
Yeah.
For petroleum engineer to work on LNG? I would say we rarely have petroleum engineers stationed on a floating LNG, but we do have petroleum engineers who work for a field that supplies gas to the PETRONAS floating LNG. So that's my answer.
So the next question is, what do you think, this is from Isni actually, so what do you think of the future of petroleum engineering since the oil is depleting?
Okay, so yes, oil is definitely a finite resources. What it means is that it will deplete over time. Okay, so I get this kind of questions a lot from secondary school students, primary school students, as well as university students when I go do my talks to them. They say, will I have a career still after 20 years? Will I be out of job by the time I graduate in petroleum engineering? And my answer is, do not worry. Based on the AEA, an organization that quantifies and collect data for the oil and gas industry. 20 years ago they said we only have enough oil and gas to last for 30 years. After 30 years they said, oh, we still have 30 more years. And why is that so? Because there are a lot more advancement in petroleum engineering. We get to extract more hydrocarbons more efficiently. And now we also explore unconventional hydrocarbons, which are actually quite vast and underexplored, if I may say it safely, with mainly accumulations. The largest accumulation are in the Americas, in Canada, as well as in Australia. So there are still demands for as long as there are energy users. If you use electricity, you would use gas to generate electricity. For as long as there is fossil fuel cars, but the emergence of electric powered cars are actually a threat to the industry, because then the demand for oil and gas becomes lower. But yes, oil and gas is definitely finite. It will deplete, but I would foresee not in the next 10 years or so. We still have a long way to go. Yeah.
So the next question is from Glossary CK. So the question is, people say you have to stay offshore for months. Is the pay worth it?
Okay. Most oil and gas companies do not allow staff to stay more than certain weeks. Okay, a typical trip offshore, if we are doing drilling, could be a maximum of 3 to 4 weeks. It never goes beyond months, because beyond months, typically, people get cranky, they lose motivation, they miss their families, they miss to see a tree, greeneries. So because of these, most oil and gas companies, do not advocate working more than 2 to 3 weeks because it's part of our fatigue management system. So we don't want our people to go tired. When they're tired, there will be accidents. And if you ask me whether the pay is worth it, okay, if you work with a service company, so service company, they do stretch their people to maximum of 2 to 3 months sometimes. Okay, but they rarely do that nowadays as well because of human rights concerns. But on a day-to-day basis, the pay is quite well if you are in the service industry. Sometimes you are being paid based on the number of days you spend offshore, and while you are not offshore, meaning on your rest days, you are not being paid if you are in the service industry. There are some companies who run like that. But generally, the pay is good. Even for me, during my younger days, I find that going offshore is fun because of the experience and the perks as well, because I do get daily offshore allowance when I go offshore. Yeah.
So if I want to just add something to that particular question, so petroleum engineers working offshore and onshore, is there a big pay gap?
Well, we always have a basic salary,
Mhm.
right? And when we go offshore, we will have special offshore allowance. And this offshore allowance really is more of like a hardship allowance for us to go work. We also get paid for meal allowance sometimes, depending on which company you work with. Comparatively, if you work just in the office, you only get your office pay, your basic office pay, plus whatever allowance that each company would offer for its typical office-based staff. Yeah.
So the next question, what is the latest technology adopted by PET in drilling?
PET, may I clarify, is it PETRONAS?
I believe so. They have just mentioned PET here.
Okay, I'm going to safely assume
Yeah.
PETRONAS. Okay, right. What is the latest technology PETRONAS uses in drilling? Well, if we are offshore, I think the latest technology that I know of at the moment is, let's see. Actually, there's quite a few that are very good. Maybe I would say extended reach drilling with special rotary drilling tools, real-time pressure and data monitoring systems. What else? There's quite a lot actually in drilling per se. And if you are drilling onshore, on land, some of the new technologies that we use are more efficient hydraulic fracturing equipment. We use microseismic. We use a lot of, more efficient use of what we call this proppants. Proppants are like small sand that we pump into the wells to keep the fracture open so that the oil and gas can flow. So it depends on where we operate, really. Yeah.
Okay, so the next question is, what is your opinion on zero carbon footprint?
Interesting. Okay, so more and more oil and gas companies are moving towards sustainability development agenda, which means they will try to reduce their net carbon footprint. What is net carbon footprint? So in a typical oil and gas environment that is easy for you to understand is if we have oil and gas production, sometimes we have to release the gas to the atmosphere. And when we release gas to atmosphere, it can be in the form of venting. It can be the form of flaring. So venting is just you release through, a conduit. And flaring is you release, but you introduce fire. So you burn the gas. So either flaring or venting would release carbon to the atmosphere, and it contributes to what we call greenhouse gas. So most companies now has advocated the net zero carbon emission, because we signed a lot of Paris Convention. Before that, it was Kyoto Protocol. So we advocate more efficient use of our processing capacity technology. We re-inject the gases, or we try as much as possible to make use of the gas for sales and reduce the flaring and venting over time. But flaring and venting are not the only two culprits. There are other contributors of greenhouse gases as well. Yeah.
So next question is from Christopher. He wants to know, as a petroleum engineer, do you have free time for yourself and time with your family?
Of course, we do a lot of time. I think work is not all. I think work-life balance makes a cut. Any engineering discipline would also have an equal, opportunity for a good work-life balance. Personally, for me, my only challenge with family is only when I have to go for my offshore trip. It will be a 5 days or 7 days trip. But for each 3 days that I spend offshore, I am compensated with 1 day of leave. Okay. So that's how I'm able to rest and also spend time with my family. But different companies will have a different policy. So really it depends. But yes, I do not spend 24 hours doing work. My working hours is just 8 hours. At the evening, I will just rest and spend time with my family.
So next question is from Zam, and he wants to know, what is the prospect for geoscientists or geophysicists in oil and gas industry?
Well, for as long as there is oil and gas production, the prospects is always real and open and as big as petroleum engineering as well. And I think geoscience, meaning if you are a geology or geophysics, you are always wanted. And there are also a lot of branches that G&G or geoscience are being at practice elsewhere. Maybe there would be a topic on geoscience itself because it's as diverse as petroleum engineering. Yes.
So Ayati also wants to know, after graduating in chemical engineering, what are the other paths that she can take besides being a petroleum engineer?
Okay, if you graduate as a chemical engineer, really you can go to any engineering disciplines, if you ask me honestly. And in fact, you can also go to non-engineering disciplines. Like, for example, where I am today in risk management, we do hire non-risk management graduates. We hire mechanical. I have petroleum engineer in my department. I do have IT graduate as well. I do have a mechanical engineering graduate who works as a risk management practitioner. Actually, the options are plenty. So don't worry if you take chemical engineering. It's one of the most versatile engineering together with mechanical engineering to go into any engineering discipline, I think, honestly. Yeah.
So we have one last question from FB Live actually. So Hanafi wants to know, petroleum engineering seems like a very specific course. Can they work and be accepted at other industry like chemical or petrochemical?
If you ask me, it's quite tough. If you graduate in petroleum engineering, really, petrochemical is not a place for petroleum engineers because we do not learn the sciences, the engineering as what in the downstream environments do. Because petroleum engineering really is actually a science. So you will graduate a Bachelor of Science in petroleum engineering or Masters in Science of petroleum engineering. It's not a Bachelor's in engineering. So although the name is petroleum engineering, so that actually differentiates it a little bit compared to chemical or mechanical or electrical or electronics. So these are some examples of real engineering degrees. So PE, petroleum engineering, is a mix of engineering and sciences.
Oh. So, Madam Norhana, we have actually come to the end of our sessions. That's all the questions we have for you today. But if the students want to contact you and ask you any other questions, would it be possible for you to share with them your email address?
Okay, I think for non-official purposes, maybe you can use my personal address.
Okay. So
yeah.
you want me to type it out in the chat?
Yeah, that would be great.
Okay.
It's Hana, Hana
Hana
__
Harun.
Harun
Okay.
@yahoo.com.
At yahoo.com.
Yeah.
So I've already shared it in the chat. So if you guys have any other questions, maybe you can personally contact Madam Norhana. With that, we have come to the end of the session for today. So thank you so much, Madam Norhana, for sharing with us your experience in the field of petroleum engineering, as well as giving a lot of valuable information for our future engineers in the audience, and also for answering our questions. So many thanks as well to our audience who have been watching and joining in on our talk for tonight. If you know someone who would have enjoyed this talk but wasn't able to join us tonight, just search for our UTP channel ANSARA TEPEN. If you look forward to learning from more of our talks like this, just subscribe and hit the bell icon. And don't forget to give our video a thumbs up if you liked our session. Again, we wouldn't have this platform if not for our strategic partners to thank for. So we have Unit Perkhidmatan Bimbingan and Counseling MRSM Taiping, Center of Foundation Studies University Technology Petronas, TNF Energy Sendirian Berhad, Amans Media, and Outpost Taiping. Let us close this session tonight with Tasbih Kifara and Surah Al-Asr. So remember to follow the SOPs. Please stay safe. With that, thank you and good night, everyone.
Thank you, Gauri. Thank you, everyone.
That was very informative.
Thank you very much, Manwana.
Thank you.
It's very interesting field, oil and gas, petroleum engineering.